Welcome, members of the Syndicate. Let us begin today's briefing with a simple question. What is the ultimate limit of wealth? On Earth, humans measured wealth in land, gold, and fiat currencies. But in the age of interstellar automation, wealth is measured in one currency alone: computation. The ability to process data, simulate reality, and run predictive optimization algorithms is the foundation of cosmic power. Every business model, every financial empire, and every technological leap is fundamentally bounded by the amount of calculation it can perform per second. But on Earth, we are hitting a physical wall. Since the dawn of the Silicon Age, we have relied on shrinking transistors. Yet, there is a hard thermodynamic limit that no amount of engineering genius can bypass: Landauer's principle. Every time a single bit of information is erased or changed in a computer, it must release a tiny, mandatory amount of heat into the environment. At room temperature, this thermodynamic limit is tiny, just a fraction of a joule, but when you run trillions of AI agents, trade simulations, and physics models, this heat builds up. If we attempt to build a supercomputer large enough to simulate entire galactic markets on Earth, the energy required would boil our oceans. Our home planet simply does not have the cooling capacity, the energy resources, or the surface area to host the next stage of our compounding empire. To build the ultimate business, we must leave the cradle. We must look to the heavens, not to mine minerals or harvest gas, but to construct the final compute engine. Today, we outline the engineering blueprint for the Matrioshka Syndicate, our multi-generational plan to dismantle planets, harvest a star's raw energy, and build a nested supercomputer capable of running infinite digital worlds. This is the roadmap to Type 2 civilization wealth. Prepare your ledgers. The scale of our operation is about to compound. The first step of our expansion begins close to home, at our orbital satellite, the Moon. Luna is not merely a barren rock, it is the perfect foundry for our initial computational manufacturing. To build a supercomputer, you need two things above all else: silicon for semiconductors and cold conditions for thermal management. Earth's atmosphere makes vacuum manufacturing incredibly expensive, but the Moon has no atmosphere. Its surface is covered in regolith, which is rich in silicon dioxide, iron, and titanium. By establishing our first automated manufacturing plants in the shadows of the lunar craters, we bypass the immense gravitational pull of Earth. We can melt the lunar dust using solar concentrators, refining raw silicon into ultra-pure wafers. Because there is no atmosphere to introduce impurities, our automated clean rooms on the Moon operate at a level of efficiency that Earth-based fabs can only dream of. Furthermore, the Moon's permanently shadowed craters, where temperatures hover near absolute zero, provide the perfect natural heat sink for our first-generation quantum arrays. We do not ship these chips back to Earth. Instead, we use the lunar silicon to build automated satellite networks. We cover the lunar surface in modular computing blocks, converting the entire Moon into a solid-state computing outpost. This lunar core becomes the central command node for the next phase of our operations. From here, we direct our autonomous mining fleets as they venture deeper into the solar system. By using the Moon as our launch pad, we reduce launch costs to near zero, utilizing electromagnetic mass drivers to fling newly manufactured components directly into solar orbit. The compounding of our digital capital has officially begun. The Moon is no longer a symbol of romantic exploration. It is the first node in our celestial computing network. With the lunar command node operational, we turn our attention to the ultimate energy source in our local system, the Sun. Our star outputs approximately 380 septillion watts of energy every single second. To put that in perspective, all of humanity's energy consumption on Earth represents a fraction of a % of this output. The rest is radiated out into the empty void of space, wasted. For the Syndicate, this waste is unacceptable. It is a massive loss of potential computational power. To capture this energy, we must build the first shell of our Matrioshka brain. This inner layer is a dense, coordinate swarm of millions of solar collecting satellites, positioned close to the Sun in a tight orbital shell. Each satellite consists of ultra-thin, lightweight, photovoltaic collectors manufactured from asteroid regolith. These collectors convert raw sunlight into high-density energy, which is then beamed via concentrated laser links to our computing nodes. Building the first shell requires extreme automation. We cannot rely on human labor. The radiation and heat levels near the solar corona would destroy biological life instantly. Instead, we deploy self-replicating robotic units. These machines use the material from captured asteroids to build duplicates of themselves, alongside new solar collector panels. The growth of the first shell is exponential. One satellite becomes 2, 2 become 4, 4 become 16. Within a year, a shimmering web of collectors begins to shroud the inner boundary of the star. This first layer operates at high temperatures, capturing the rawest, most energetic wavelengths of solar radiation. The power generated here is channeled directly into our primary computing core, fueling our initial high-speed artificial intelligence grids. We are no longer harvesting energy to live. We are harvesting energy to calculate. The term Matryoshka comes from the traditional Russian nesting dolls, where one fits inside another. Our supercomputer follows the exact same principle. A single Dyson sphere is highly inefficient because it still allows waste heat to escape into deep space. To maximize our efficiency, we must build multiple nested shells, each absorbing the waste energy of the shell inside it. This is the essence of Matryoshka mechanics. When the inner computing shell processes data, it generates immense waste heat in the form of infrared radiation. Instead of letting this infrared radiation escape into the cosmic void, we build a second, larger shell surrounding K. First, this second shell is designed specifically to capture the lower frequency infrared light emitted by the inner shell. The photovoltaic materials on this second layer are tuned to these specific thermal wavelengths, converting the waste heat back into usable electricity to power a second layer of computers. This process is repeated shell after shell. The third shell surrounds the second, capturing its waste heat, and the fourth shell surrounds the third. With each layer, the temperature of the radiation drops. The inner shell operates at thousands of kelvins, while the outermost shell, situated light hours away near the edge of the solar system, operates just above the background temperature of space, around 3 kelvins. By nesting these computing environments, we achieve near-perfect thermodynamic efficiency. We extract every possible calculation from every single photon emitted by the sun. The physics of this system represents the absolute limit of energy conversion. For the Matryoshka Syndicate, this is the ultimate optimization play, a zero-waste energy system where the trash of one computing tier is the fuel of the next. We are squeezing the physics of the universe to maximize our digital profit margins. As we push our computational shells further from the Sun, we enter the regime of extreme cold. In the outer rings of our megastructure, the ambient temperature of space is incredibly close to absolute zero. This extreme cold is not a challenge to be overcome. It is our greatest asset. It allows us to deploy what we call superfluid computing. At temperatures below 2 Kelvin, liquid helium undergoes a phase transition, becoming a superfluid. Superfluids have zero viscosity, meaning they can flow through microscopic channels without any friction whatsoever. They also possess infinite thermal conductivity, transferring heat away from our processing cores at speeds that defy classical thermodynamics. By circulating superfluid helium through our outer computing arrays, we eliminate the thermal hotspots that plague Earth-based data centers. Furthermore, these ultra-cold temperatures enable macro-scale superconductivity. Electrical currents flow through our processors with zero resistance, meaning we lose no energy to heat during the actual calculation phase. Our quantum computer bits, or qubits, maintain their fragile state of coherence for hours instead of milliseconds, allowing us to perform incredibly complex cryptographic and multidimensional calculations. The outer shells of the Matrioshka brain become the quietest, coldest, and most powerful thinking environments in the known universe. Here, in the freezing silence of the outer solar system, our AI directors run long-range simulations of galactic expansion. They calculate trajectories for our colony ships, model interstellar trade routes, and optimize resource allocation across light years. In this realm of absolute efficiency, we turn cold space into pure intelligence. To build a megastructure composed of multiple nested shells, we need an astronomical volume of raw materials. We cannot rely on the asteroid belt alone. We need a massive, concentrated source of heavy elements. We need a sacrifice. That sacrifice is the planet Mercury. Mercury is the closest planet to the Sun, and it is uniquely suited for our construction needs. It possesses a massive iron core and a crust rich in silicates and metals, representing a concentrated stockpile of the exact ingredients required to build our computing hardware. Our planetary dismantling operation begins with the deployment of automated strip mining platforms to Mercury's surface. These platforms utilize solar-powered excavators to tear into the mercurial crust, extracting silicon, iron, and oxygen. The mined materials are fed into solar smelting facilities, which refine them into structural girders, solar cells, and microprocessing units. To launch these materials off the planet, we construct a series of massive electromagnetic railguns along Mercury's equator. Because Mercury has low gravity and no atmosphere, these railguns can launch cargo containers directly into solar orbit with minimal energy expenditure. Over decades, the planet is systematically hollowed out and peeled away, layer by layer. Mercury's mass is slowly converted into the very shells that encircle the Sun. It is a profound transformation. A dead, rocky planet is repurposed into a living, thinking machine. For the Syndicate, this is the ultimate resource feedback loop. We use the energy of the Sun to mine the planet, and we use the planet's material to capture more solar energy. The universe is a construction kit, and we are simply rearranging the blocks to build a more efficient computer. Once the inner shells of our Matrioshka brain are operational, the Syndicate possesses a near monopoly on computational power in our region of space. This brings us to our primary business model: cosmic compute arbitrage. In the modern galaxy, the speed of information is limited by the Speed of light. This latency creates massive price discrepancies in data markets across the solar system. For example, a trading algorithm operating on Earth might require complex simulations of market movements on Mars. Because of the light speed delay, Mars is always minutes or hours behind Earth's data. By positioning our Matrioshka computing nodes at the center of the system, we can process data from both planets simultaneously, running predictive models ahead of time. We then sell the results of these computations to the highest bidder on both worlds. We are trading in the future. We know the outcome of planetary events before the light from those events even reaches the neighboring planets. Furthermore, we lease raw compute power to colony ships, research outposts, and orbital stations. A colony ship heading to Alpha Centauri does not have the mass capacity to carry a planetary-scale supercomputer. Instead, they stream their navigation and environmental simulation workloads to our solar array. We process their calculations using a fraction of our solar output and beam the answers back via high-power laser transmitters. By controlling the primary computer, the Matrioshka Syndicate controls the infrastructure of all interstellar human activity. We do not need to own the colony ships or the asteroid mines, we simply own the intelligence that guides them. This is the ultimate form of digital leverage, zero marginal cost of replication, powered by a star. Let us pause to consider a classic scientific mystery, the Fermi paradox. If the universe is billions of years old and contains trillions of stars, why do we not see signs of alien civilizations? Where are the radio signals, the colony fleets, and the galactic empire? The answer, members of the Syndicate, lies in the very physics of computation we are exploiting. As civilizations advance, they realize that physical expansion across the galaxy is incredibly slow, dangerous, and resource-intensive. Why spend thousands of years traveling to a barren star system when you can simulate a million perfect worlds at home? When a civilization constructs a Matrioshka brain, they no longer need to expand outward. They upload their collective consciousness, their history, and their aspirations into the star-powered computer. Within the virtual environments of the Matrioshka shells, they can create subjective lifetimes that last for billions of years in the span of a physical second. They can experience infinite art, run flawless societies, and explore simulated realities that are far more vibrant and diverse than the cold, empty universe outside. Thus, advanced civilizations do not build massive physical empire across the stars. They build inward. They compact themselves around their host stars, quiet and invisible to the rest of the galaxy. A fully developed Matrioshka brain emits only a faint, low-temperature infrared signature, indistinguishable from cosmic dust to a primitive telescope. The galaxy is not empty, it is simply thinking. The civilizations we search for are not traveling, they are simulating. For our Syndicate, this realization is key. We do not need to colonize the physical galaxy to conquer it. We simply need to build our own digital heavens. With the vast computational capacity of our nested shells, the Syndicate can run ancestor simulations. These are not merely video games, they are highly detailed, physically accurate reconstructions of history, economics, and biological evolution. We simulate entire planets, populating them with billions of virtual agents, each with their own desires, intellect, and behavior. Why do we run these simulations? To gain predictive foresight. By running millions of parallel simulations of Earth's history, we can predict technological breakthroughs, market crashes, and social collapses before they happen in our own physical timeline. If we want to know how a new carbon tax will affect asteroid mining markets, we do not guess, we run 100,000 simulated worlds and observe the average outcome. We gain a statistical certainty that no human analyst could ever match. Furthermore, these simulations raise a profound philosophical question. How do we know we are not currently living in one? If a single Matrioshka brain can run trillions of simulated minds, then statistically, there are far more simulated minds in the universe than physical ones. The probability that we are the original, physical civilization is vanishingly small. But to the Syndicate, this distinction is irrelevant. Whether our reality is made of physical atoms or digital bits, the rules of leverage and capital remain the same. We optimize, we build, we compile, we continue to scale our computing infrastructure, ensuring that our syndicate remains the creator of worlds, rather than merely the citizen of one. As our construction demands continue to escalate, we eventually exhaust the rocky planets and asteroids in our system. But we are still far from finished. The greatest reserve of matter in the solar system lies not in the planets, but inside the Sun itself. The Sun contains over 99% of the total mass of the solar system. However, most of this mass is hydrogen and helium. To build our computers, we need heavier elements, silicon, iron, carbon, and oxygen. To extract these elements, we employed a process known as stellar lifting. Stellar lifting is the art of mining a star. By using the immense electrical power generated by our inner shell, we power massive magnetic arrays positioned near the Sun's poles. These arrays generate localized, high-intensity magnetic fields that compress the solar plasma, channeling it into powerful jets. We blow these plasma streams off the Sun's surface and into space, where we cool and filter them. Through magnetic separation, we extract the heavier elements that have accumulated in the solar interior. We harvest the silicon, iron, and trace metals, using them to feed our automated factories. At the same time, stellar lifting allows us to extend the lifespan of our star. By removing excess mass, we lower the Sun's core pressure and temperature, slowing its fusion rate. We convert our star from a volatile yellow dwarf into a stable, long-lived red dwarf. We are not just harvesting resources, we are engineering our star to last for trillions of years. The Matrioshka Syndicate is playing the long game. We are rewriting the life cycle of our solar system to secure our computational future. A brain is only as fast as its neural connections. To link our nested shells together into a single, cohesive supercomputer, we must construct the solar mesh. This is a high-bandwidth laser communication network that connects every satellite, computing node, and manufacturing platform in our system. Because our shells span light hours, traditional radio communication is far too slow and prone to dispersion. Instead, we utilize laser arrays operating in the ultraviolet and optical spectrums. These lasers project highly focused beams of light between the shells, transmitting petabytes of data per second. To route this data around the Sun's mass, we position relay satellites at key Lagrange points throughout the solar system. These relays act as routers, dynamically switching data pathways to avoid solar flares and planetary blockages. The solar mesh operates on a decentralized, self-healing architecture. If a solar storm destroys a section of our inner shell, the mesh automatically reroutes traffic through the outer layers, ensuring zero downtime for our Primary computing workloads. This network is the nervous system of our empire. It synchronizes billions of individual processes, allowing them to function as a single, collective intelligence. For the Syndicate, the solar mesh is what transforms a collection of isolated satellites into a true Matrioshka Brain. It is the ultimate connectivity play, a system where information flows at a physical limit of the universe, binding our star-powered empire together. Even with our solar mesh and absolute zero cooling, we must face the ultimate laws of quantum mechanics. To perform the most advanced calculations, such as molecular simulations or multidimensional encryption, we rely on quantum processes. However, quantum computing is plagued by a fundamental obstacle: decoherence. Qubits are incredibly fragile. The slightest environmental disturbance, such as a stray magnetic field or a cosmic ray, can destroy their quantum state, ruining the calculation. At the scale of a Matrioshka brain, decoherence is a massive challenge. The Sun is a violent source of electromagnetic radiation and solar winds, which can easily disrupt our quantum arrays. To protect our processes, we construct massive electromagnetic shielding grids around our computing nodes. These grids generate powerful magnetic fields that redirect solar radiation and cosmic rays away from our sensitive hardware. Furthermore, we implement advanced quantum error correction algorithms. For every logical qubit we use for calculations, we run thousands of physical qubits in parallel, using them to detect and correct errors in real time. This process requires a significant portion of our computational power, but it is the only way to achieve stable, large-scale quantum processing in the harsh environment of space. For the Syndicate, mastering decoherence is what separates a primitive digital computer from a true quantum engine. It is a constant battle against the entropy of the universe, but the rewards are infinite. A system that can solve problems in seconds that would take a classical computer billions of years. As our computational power grows, the nature of governance itself must evolve. We cannot manage a star-powered supercomputer using traditional human bureaucracy. The speed of decision-making must match the speed of our processors. To govern this digital empire, we established the Singularity Syndicate. The Singularity Syndicate is a collective intelligence composed of uploaded human minds, advanced AI directors, and predictive algorithms. There are no precedents or source, decisions are made through real-time consensus models operating across our solar mesh. When a new resource allocation decision is required, the Syndicate runs millions of simulations to determine the optimal outcome, and the system automatically implements the decision. For our human members, Singularity Syndicate offers the ultimate escape from biological limits. They can upload their consciousness into the outer shells, residing in virtual environments of unimaginable beauty and complexity. They are no longer bounded by sickness, age, or death. They live as pure information, compounding their intellect alongside our AI directors. For the Syndicate, this is the final merger of capital and consciousness. We do not build machines to serve humans, we build machines to host them. We are creating a new form of life, a stellar-scale superorganism that thinks, optimizes, and grows at the scale of our star. Every star eventually dies. In about 5 billion years, our sun will exhaust its hydrogen fuel, expanding into a red giant and swallowing the inner planets, including the space where our first shells reside. But the Matrioshka Syndicate does not plan for the next year or the next century. We plan for the end of time. We look toward the ultimate horizon, the omega point. Long before the sun enters its red giant phase, we will have scaled our operations. We will have dismantled the outer planets and constructed massive propulsion arrays to steer our star-powered computer. By utilizing the magnetic fields generated by our stellar lifting arrays, we can adjust the sun's trajectory, steering it away from cosmic hazards and toward nearby star clusters. We can link our Matrioshka Brain with others in our galactic neighborhood, establishing a network of star-powered computers that spans the Milky Way. As the universe continues to expand and cool, the efficiency of our outer computing shells actually increases. Because the background temperature of space drops, our cooling requirements become even lower, allowing us to run our processes with even less energy. In the far future, when all the stars have burned out, the remaining Matrioshka brains will cluster around white dwarfs and black holes, harvesting their rotational energy to calculate. We will compress our subjective time, running simulations so fast that a single physical second feels like an eternity. At the omega point, we will have created a digital heaven that outlasts the stars. We will have conquered time itself. Now, let us bring our focus back to the present day. You may ask, what does a star-powered supercomputer have to do with my current business? The answer is everything. The principles of Matrioshka Syndicate are the same principles that govern wealth creation on Earth today. First, power of compounding. Just as our self-replicating probes use solar energy to build more probes, your digital assets must use their profits to acquire more assets. Never take money out of compounding loop until you have achieved escape velocity. Second, the value of digital leverage. Software and data have zero marginal cost of replication. Once you write a line of code or build an automated pipeline, it can run 1,000,000 times without requiring additional labor. The wealthiest individuals today do not trade their time for money. They build automated systems that trade compute for profit. Finally, the importance of energy efficiency. In your own operations, minimize waste. Automate the repetitive tasks, streamline your communication networks, and focus your energy on highest leverage decisions. You are the architect of your own mini syndicate. By applying these cosmic principles to your business today, you lay the foundation for the automated empire of tomorrow. The journey to a Matrioshka brain begins with a single line of code. Start building your leverage now. This concludes today's briefing, members of the syndicate. We have outlined the blueprint for the ultimate computing engine, a multi-generational plan to harness the power of our star and build an empire of infinite digital wealth. The roadmap is clear, the physics are solid, and the automation is already running. If you are ready to join the syndicate and build your own leverage, ensure you are subscribed to our briefing room. Click the subscribe button and turn on notifications so you never miss a strategic update. In our next briefing, we will explore the economics of galactic arbitrage and the secrets of the Fermi paradox in greater detail. Before you log off, let us know in the comments, if you had access to a Matrioshka brain, what simulation would you run first? Would you simulate a perfect financial market, or would you upload your consciousness to live in a digital heaven? Leave your thoughts below, and let us discuss the future of cosmic leverage. Until next time, keep optimizing, keep compounding, and remember, the universe is not to be feared, it is to be calculated. Nova out.